recording now. This is continuing on lesson 1, which is the unit circle and solving using the unit circle. And you need your calculators out as I keep going on about. And we're doing the one down the bottom. This is all what you need to know before you start stuff. We're talking about the unit circle and all that bizzo. But this page is just purely practicing graphing, like finding x-intercepts. So this one, you're asked to use the graphing functions on your GDC to solve the equation. So what do you think you would do to solve this one on the GDC by graphing?
Rearrange. Oh, you could just do 1 in y1, 1 in y2.
Yeah, that's right. Graph this one in y1, graph this one in y2. So let's write that. So what is that in y1? Graph y1 and graph in y2. Graph in y1, graph in y2, then then what you do after you graph it in y1, y2, and then to solve for x, what do you press?
Second.
Yes, second.
Something 0.
Second calc. Yeah, zeros are to find the x-intercept.
Intersect.
Intersect.
Because you have to find.
Yeah, intersect. So it either says intersect or intersection, I forget.
Isn't that 5?
Something like that. Yeah, it could be.
I mean, you should not be really.
Second calc, but look for the word intersect because you're looking for what are the points where the two graphs intersect each other. And then don't forget after that you've got to press enter.
It is 5.
It is enter. Okay, good. Enter. Okay, so whichever one says intersection because you're finding the intersection of two graphs. So let's do that now. Let's graph our stuff.
I always get it more than
You know, it could be worse.
it could be yours.
What?
Exhibit A.
What?
Exhibit B.
What? I don't know. No. Minus 5x. Okay, so x cubed minus 5x. I hope I typed in the right thing there. Then in y1 you do square root of x plus 1. Then you've got to press graph. And you need to be able to see where they intersect. If you can't see where they intersect, you need to adjust your window. This one, yeah, we can see them. So there seems to be, this one's a cubic. So you've got a cubic kind of function going on. And then you've got the square root of x plus 1. And then there's 2 intersection points. So that's when we do our second calc, intersect. And then I just go straight to enter. And it's going to find the one that it's closest to. So that's...
This one, negative 1.8.
Yeah, something like that.
Negative 0.18.
Yeah. Oh, I don't actually have my answers. Where are my special answers?
Practical.
Down here.
And then you put it in y1.
You're welcome to put that on.
The first stuff in that.
Oh, I put the equal sign.
No.
Well, can't I did everything. Wrote it in y. I do my average on being naturally.
What?
I do my average y2 to b.
So I wrote it unrounded first, in case you need the unrounded later to do something. And then write it rounded, because if you need to use that answer in a later question, you need the unrounded answer. But for the answer to this one, you would put the 360 one, but then write the unrounded before it. And then don't forget there's another one. So that's one intersection. So notice that, so now there's another one. It found the one that it's closest to. So what do we do to make it find the other one? Yeah, that's right. You arrow to the right a bit so that you can find the other one. So I press enter, and before I press enter, you can either scroll across first and go second calc, or you can press second calc, intersect, and then once you're closer to it, enter. and then
Enter.
and then it says intersection. You've got to keep going till it says intersection, and then right unrounded again.
So funny. What are you saying back there? Wait, you don't understand it? Tell me faster.
Standard is not for that.
After lunch?
We don't have
Hey, cool, I didn't do my homework.
Same.
Yeah. I didn't even know.
You guys have Spanish homework?
We can't have and then when we had economics in grade, it said, like,
I didn't realize.
she did.
So if for some reason you were required to show working out, what's something you could show for working out for this? Yeah, do a quick sketch of the graph. Yeah. So you could do a little quick sketch of the graph. I'll just be lazy and I'll get it from here. So a little quick sketch of the graph might be a good thing to pop in. There you go. It's getting a bit noisy. There you go. So a little sketch of the graph you can pop in. There's another question over here, so let's just quickly do that so we can become experts at this. So let's go y equals, it's x to the 4. So x to the power 4, and then 3 minus x squared.
I can't wait for our
Huh? The topic? Or do you mean your exam? It's kind of fun. It's fun. It's nice when it's a nice feeling when it all kind of comes together. Interesting. So again, 2 little intersects.
No, but our exam schedule is stupid because in the real one,
we get math done like in one day or like one afternoon and one morning.
the Miss McMahon, she makes them up like some.
Like it's economic psychology, economics. Where in your real exam, you will get economics done one time. Technically, that's not even a real mark because it's not exactly like the real one. Like if I was economics and psychology, like some people are, that's gonna be hell.
Because they have to get the economics one and switch to psychology and switch back to economics.
Yeah.
It's crazy.
And I want to study for it.
If I was in psychology, I would be blind. Trust that.
There you go. Second calc. F5. Alright, closer to the other one.
Miss McMahon, what's up?
Very late to do my math by the way.
Oh.
That's why I came late this morning.
But GeoGebra is stupid. I had to put in the
So
data
annoying.
5 times and it wouldn't save.
It's annoying.
So
Oh,
I had
really?
to keep, because you know how you able to copy paste it, but I couldn't.
Oh, yeah.
So I had to put each individually for like 96, 2014, like 10 times because it wouldn't save.
Maybe, have you got it in the Google Doc? Because maybe it'll copy and paste from the Google Sheet.
But still, I would have to
Oh, from the
Copy and paste it from the Apps website to the Google Sheet. Like I was never able to open it as a spreadsheet.
Oh, that's annoying.
I
Okay.
do know it's on the laptop.
That's so irritating, isn't it? And it'd be fine if all you had to do was find it by technology. The fact that ladies don't have to assign a model by hand. You can't do that on Excel.
That's what I mean. That's what he's sucking.
Yeah, this is for the second one. There's a second question up here somewhere. So you'll probably get x equals.
Are you typing loud to make us be quiet?
There you go. So just reminding you to write your unrounded answer, and then your rounded answer.
Oh, it's ready. You're fine.
Huh? So I think you guys have it by now. It does take a while. I've worked out my answers already.
Oh, so you're not.
Yeah, so that one, but this one down here is the answer to that one up there. Yep, so this one down here is the answer to that one up there. Because there was a part A and which is here in green, part B, which is here. So remember, unrounded, then write your rounded. If you maybe can be safe to do a quick sketch as well. There's a little method step, unless it's only worth too much.
Finally on lesson 1.
Yeah. Yeah, you're good. So now this is kind of going back to the fundamentals of the unit circle. Where's my L1? Here it is. Okay, cool. Yep. Oh yeah, right.
You already have this.
Okay, the unit circle explains how values of sine and cosine are even created to begin with. It is located on a coordinate plane and it has 4 quadrants. Yeah, good. Quadrants. Good. And now let's mark them in. We've got quadrant 1, 2, 3, and 4. Okay. So mark in our quadrants, 1, 2, 3, 4. Maybe let's mark in some degrees as well. Like 0 degrees would be here. What degrees would be here? 90. Yeah. Over here. What degrees would be down the bottom?
270.
270, yeah.
Like 90 and that's 270. All in all that I received.
70 degrees. Maybe also for fun, let's put the
Okay.
let's put the radians as well.
Fun! What fun?
Is it pi? Remember pi radians?
Pi radians.
Okay, Kobe, I think
That's important to remember. Pi radians.
0.5, 1.5.
Yeah, or pi over 2. Don't forget it's pi over 2. Or 1.5 or 0.5 pi. And then this one would be pi radians. And what would this one be? Is that 3 pi over 4?
No.
3 pi over 2, yeah. Sometimes they can make that mistake just because you're thinking 4 quadrants and all this kind of stuff. So it's actually 1.5 pi. And then over around to here again, you see 2 pi. And same with that one, that would be 360 degrees.
Do we split it into like, I'm not talking, you are.
What's that, sorry?
Would we split it into first?
Sometimes, yeah, like maybe the question's requiring you to do pi over 3, which would be 60 degrees, wouldn't it? Yeah. Or 2 pi over 3, which would be 120 degrees. Nice. Yeah, so I think that's all the stuff we wanted to write down on there. So by definition, the unit circle has center with coordinates.
0, 0.
0, 0 is the center. Just see here, 0, 0 is the center. And a radius of 1 unit. Good. Just by definition. A radius of 1 unit. Keeps the numbers easy. Now, if we draw a point P on the circumference, I'll do that with purple maybe. If I draw a point P on the circumference of the unit circle, its vertical height will be, first of all, let's just do that. Oh gosh, I didn't mean to do that. So just put a P, probably somewhere in the first quadrant's easy. Mark in point P. Ding, ding, ding. And then maybe with another colour. Maybe this nice mauve. Dun, 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 dun. There's a thing. And then I'll mark in a little triangle here. So I'm marking in the horizontal distance. Well, the x-coordinate, the y-coordinate. That's meant to be a P. This is just a radius, of course. And notice it's a right-angled triangle that's been generated with an angle of theta. So what I've done is, in case it's hard to see what I've done, that's point P, we've just marked somewhere in the first quadrant. That's the vertical distance, or the vertical height of it. Basically the y-coordinate will be this distance. Its x-coordinate would be that horizontal distance, and it's got an angle theta that's made here. And this is all, what I'm trying to do is prove why this is sine theta. What is the radius again? The circle 1. So maybe let's mark that in because that might help us to see that. So the radius is 1. So I'm trying to prove to you why this height here is going to end up being sine theta and why this length, green length here, is cos theta. So that's what we're about to do.
Well, because sine is the height and cos is 0.
Yeah, and it's all to do with like using SOHCAHTOA, sine theta equals
Opposite of
close. Yeah, opposite of hypotenuse. And the triangle we drew was kind of like this. And it had a nice green here. And then it had a 1 going on here. And it's right angled.
Why do we have to use sine?
Because we're talking about the purple.
Oh, okay.
It's height, yeah. So good. So why are we using sine? Because we're talking about the height. The height of the point P. So here's point P here. So using SOHCAHTOA, it will be the opposite. Well, the angle, by the way, is down here. So the opposite, it would be the opposite over the hypotenuse. So sine theta equals the opposite over the hypotenuse. Yeah. Okay, and so which equals opposite over, what's the hypotenuse equal to? 1, yeah. If you rearrange that to make it the opposite, maybe put OPP, so we don't by mistake think that's 0. So if you rearrange to make it opposite the subject, what would you multiply both sides by? By 1, yep. So 1 sine theta, 1 sine theta equals the opposite length. So would you agree, therefore, that the height is the opposite of the angle is equal to sine theta then? So sine theta equals the height. So you might just want to put therefore. Sine theta equals the height. That kind of vertical height there. And it's all because like when you plug in the hypotenuse of 1 into sine theta equals opposite over hypotenuse, timesing by 1 just means that the opposite equals sine theta. So that's just a little quick proof. Why do I keep saying the height is sine theta? And now we're just going to similarly show why the horizontal length, the base of the triangle, is cos theta. Let's give us a bit more space here. So similarly, its horizontal distance from the y-axis using SOHCAHTOA, that thingy majiggy will be, the horizontal distance because we can use cos theta equals, what is cos theta equal to in SOHCAHTOA? Yeah, adjacent over hypotenuse. So let's plug in the hypotenuse of 1 again. So cos theta equals adjacent over hypotenuse, which was 1. And then to solve for the adjacent, we transpose to make the adjacent the subject with times by 1. 1 cos theta equals the adjacent. So therefore, cos theta equals the base of the triangle, or the x-coordinate of point P. So the horizontal base. So in a way you could say, so point P has coordinates P, and then its x coordinate, because you do x then y, x coordinate would be cos theta. Cos theta. And its y coordinate would be sine theta. So that was just to prove why I keep going on about saying that the height is, or the y coordinate is sine theta and the x coordinate is cos theta. It's all because when you plug 1 into SOHCAHTOA, you've got a hypotenuse of 1, because the unit circle radius is always 1, and timesing by 1 just means that side becomes sine theta, and that side becomes cos theta. So again, just to try and prove why that's the case. So now at this point we can therefore just accept that and then just move on and start using the unit circle. Here we go. So again, just label the quadrants again on the unit circle below. We'll just practice labeling things. Sometimes people forget which direction the quadrants go. So we'll do one more where we label it all, just so it goes into our long-term memory a bit more so. And we've got a degrees. Radians. 0 radians. 2 pi. 3 pi over 2. Okay, 3 pi. I keep forgetting 360. going in this direction, isn't it? And our normal point here. Now we know point P, marking that its height would be sine theta, and that its vertical length, horizontal length here would be cos theta. And it's got a radius of 1. So this is just summarising what we know so far. And the coordinates of P, we could also point out as being sine theta plus theta.
Isn't it cos theta sine theta?
Yes, it is. Thank you. X before Y. Right. Ugh. This race. Okay, so you cos theta and sine theta. X and Y. So I think that was a summary so far. Yep. Nice. Practicing our little thingamajiggy. Can anyone remember from last lesson? Is sine in the first quadrant? Is sine theta positive?
Yeah.
Yeah, you can see positive height. In the third quadrant, is sine theta positive?
Nope.
Nah, because you'd get a negative, wouldn't you? Triangle going like that. What about in the second quadrant?
Yeah.
Yeah, because it's kind of, you get this triangle going on. And fourth quadrant? Nah, it's negative, yep. Cos theta, where is cos theta negative?
And the
Second quadrant and third.
Second and third quadrants, yep, because then it would be a backwards. You'd have a negative x coordinate for the length. Good. Tan, what's the formula for tan theta?
sine theta equals theta.
Yeah, that's one of the trig identities, just pointing out that it is also opposite over adjacent, like if you're using the other thing. But remember, this thing tan theta equals sine theta over cos theta can help us to realise that tan theta, would you agree tan theta must therefore be positive here because it's a positive divided by a positive? Where would tan theta where else would it be positive?
Third.
The third, yeah. Why is that?
Because inside of both negatives.
Yeah. Good, yeah. And negative divided by negative. And would you agree negative here?
Yeah.
Because it's like a
Positive.
positive divided by negative. Good. And negative here because it's a neg divided by positive. Good. I'm on the wrong page. Here we go. So this might help us to fill in these things. We now realise that the value of sine theta is the something of the triangle, height of the triangle. So just summarising the stuff we found. Is the height of the triangle, or the y coordinate of the point P, and the value of cos theta is the length, or you can call it base if you want. Length or base, horizontal length. You can fit it in. Base of the triangle, or you can think of it as the x coordinate of the point P. The length of the hypotenuse will always be. Just going on and on about this stuff because it's kind of helpful to know. That's a unit circle by definition has a radius of 1. Some people ask why is it 1, and it's just the people who came up with this unit circle as a way of explaining trig functions just said it's going to be 1. Okay, so therefore it makes sense. So this is kind of just what we were talking about then. It makes sense that the value of sine in quadrant 1 will be positive or negative. Yeah, positive. Positive green, isn't it? Where else is it positive? Second, yeah. So therefore, next year, it's the negative y coordinates in these ones. And cos theta is the x coordinate.
I thought it was the other way.
It is, yeah. No.
No, that's right.
Yeah,
That's
that's
the x and
yeah.
it's unsine to 1.
Yeah. So see, sine is the height.
Oh.
Yeah. Yeah, because you're thinking coordinates cos theta, sine theta, maybe.
I was just like, I was looking at like which one it comes from, not which like one it is.
Oh, okay, yeah. These puzzling stuff. So yeah, ask away. Clarify all this kind of stuff. Because a lot of people probably have similar questions. Okay, so similarly, the value of cos theta. Where is cos theta negative?
2 and 3.
2 and 3, yeah. No. Yes. Negative.
Yes,
and negative. Because they're negative x coordinates. What's on P in that case? Positive and positive. Hurrah! This is actually a big thing. So what these things, knowing these things is a little bit, turns out to be a bit of a big deal. So it's good to, like, some people just memorize it for an exam, but it's good to realize why. So if you forget, you can understand it. Yeah. Yeah, some people memorize, but memories can be a bit hazy, so it's good to understand it and be able to go back and draw a unit circle and rationalize. I've got a big, crazy table to fill in. Ta-da! Special triangles. Sketch the 2 special triangles, and label their side lengths. I sometimes put a unit circle here just in case it's helpful as a reference to look at. So your 2 triangles, what is one of them? Yeah, 45, yep. The 45-degree one. That's good. By 45. Okay, I'm going to calibrate again. What's the other triangle? 60-30, yeah. So the 60-30 one is the one I draw quite exaggerated. So you can see which side is the longer side, which side is the shortest side. It's not like that. There we go. And this one is 30. So I draw it exaggerated, so it's really obvious which one's 30 and which one's 60. And remember, the shortest side is always opposite the smallest angle. And the longest side is always opposite the biggest angle. What's our side length for the 45?
1/2
root 2. And for the 60?
1/2
Yeah.
1
So root 3 is like 1 point something. So that's why it's not the hypotenuse. And I've got this here just in case it comes out. 1, 2. So, using our lovely little SOHCAHTOA, kind of like what we did in our little warm-up, sine theta is opposite over hypotenuse. But even better, like for 0 degrees, 0 degrees is kind of just a line that goes across. What's the height of that line?
0.
0, yeah.
You got me yet again.
0 degrees for that one. Similarly, 90, you're just kind of going straight out like this. What's the height of that?
1.
1, yeah.
How can you get all the way to the same?
It's just the easy ones. Do the easy ones first. And then the 30-degree ones. So imagine this 30-degree triangle is kind of here. You got a little bit. The angle's got to be always down here, down in that corner.
1. The height is 1. Oh no.
1.
Yeah, because it's not a triangle thing.
Oh yeah. In this case, sorry. Yeah. In more so, it's like sine theta is opposite over hypotenuse. So like this kind of stuff, like sine theta. So it's going to be like a fraction opposite over hypotenuse. Sorry. Yeah.
Yeah,
So it's
so
not to do with. In a way, like I was just trying to say, if it was in the unit circle, it would look like that. But then you just look at the triangle to work out what's the opposite over the hypotenuse.
isn't the opposite 1? Isn't the opposite 1?
Yeah, yeah. I thought you were talking about the overall answer was 1.
No.
Yeah, it's a half. Yeah. So 1 over 2. Opposite
You know
over
what?
2.
She's supposed to ask about 1.
No, I was saying the height is 1.
This is how she questions.
Yeah, this is what she questions. That she doesn't
Is that the
understand
height is
us.
Okay, never mind.
Well, it's partially different. It's a different thing. And also divine theory.
Imagine we watched it in class, like, I'm only partially listening.
Okay. So I don't know what that thing's there. It's annoying. So 45.
I like this.
Opposite
Root over
over
2.
2. 1 over root 2.
Because
Yeah.
it's 1 over root 2, and then you have to get rid of the.
Yeah, exactly. Yeah. 1 over root 2. And we'll just do one example of those so we don't have to do it every time. Equals. If you have to quote it as a final answer, root 2 over 2. Sometimes they carry the exact, sometimes they don't. If it's just in your working out, leave it as 1 over root 2 and then rationalise your final answer. So, but then if it's a final answer, it's times basically rationalised. Sometimes they don't bother penalising you, but you just don't know if they will or not.
Oh, bless you.
Did anyone just sneeze or was something?
Okay, so now we've got 60. So for a sign of 60 instead.
Root 3 over 2.
Yeah, root 3 over 2.
Probably like, we need some torture.
Root 3 over 2. Similarly, cos of theta, if it was 0 degrees, what's and it's all the way across? What would that be?
0, 0, 0, 0, 0.
Remember it's a horizontal?
1.
Yeah, what's the x coordinate of point P if it's over here? 1. Yeah, exactly.
One.
Positive 1, yeah.
1.
I just want other people to get it too.
Oh, yeah,
Wait.
Cos theta at 0 degrees.
Cos theta is
1, adjacent to hypotenuse.
Belly.
So,
how do we get
It's
that?
all about
Because technically cos theta,
I asked why.
if you've got your point P here,
yes.
a trend.
cos theta is its x
You also
coordinate.
have a pattern.
You just work it up.
Yeah.
Owen math.
Yeah, and to prove that, if you typed in cos 0, you'd get like 1. And then cos of 30, what's that there?
Adjacent over opposite.
Yeah,
No,
adjacent-
hypotenuse.
yeah,
Over
adjacent
3
over-
over 2.
Yeah, root 3 over 2. Kind of go through them a bit faster now. Cos of 45.
How do you know? 1 over root 2.
Yeah, which super
2 over root 2 over 2.
Yeah, root 2 over 2. Yeah. Cos of 60.
1 over 2.
0.
Yeah, it is 0. Why is it 0?
Because it's the opposite of sine.
Fabulous. Good. And also, yeah, that's true. There's that. And also, like its height, sine theta, cos theta is cos this is its horizontal distance from 0, and there is, like, its x coordinate of that point P would be 0.
Stop. Wait, I don't understand.
Yeah. So 90 degrees would be just a line going up.
Stop it. Stop
It's got a height of 1.
I can see it.
It's got a height of 1. So its y coordinate would be 1. Its x coordinate of that point would be 0. Yeah, and cos theta is the x coordinate as you spin it around. And sine theta is the y coordinate of each point as it kind of moves.
Yeah, I don't know.
Why is it 0? Yeah, so 90 degrees would be a line going up to here. So point P would be just here. What's its x coordinate at that point?
0.
Yeah, and that's what cos theta is. Yeah, cos theta is the x coordinate. Sine theta is the y coordinate of that point. And then, right, so tan theta. What's our little formula for tan theta as well?
Sine over.
Yeah, so tan theta. Or you could use opposite over over adjacent, but also this is good to be aware of this formula, sine theta over cos theta. Sine theta over cos theta. Which kind of makes it easy to work out then. So what you could do is to work out tan theta, you could just do sine theta divided by its cos theta. Good guess, 0 divided by 1. 0, yeah. But it's good that you're thinking about that. Yeah, it's good that you're thinking like that.
Almost there.
Almost. What's 10 times 10? Almost.
And then for tan of 30, just use the triangles. Tan of 30, what was that?
Root 3 over
10 30 opposite over adjacent. Yeah, 1 over root 3.
Can we just make sure everyone's listening?
1 over root 3.
I got 1 over root 3.
Yeah, 1 over root 3, because what we're using to...
Because the opposite is 1, the adjacent is 3.
Yeah, and then to rationalize the denominator, what could you do?
Root 3 over 3.
Or is it root 3 over root 3?
Yeah, root 3 over root 3, sorry, yeah. Which is the final answer, therefore, as Sarah was saying. Yeah, root 3 over 3.
Wait, how is it 1 over root 3?
Opposite over adjacent. So tan of 30, opposite over adjacent.
Oh, but I thought.
Oh, and also, if you did 1 over 2 divided by root 3 over 2, you would get root.
Oh, you would. Okay.
Yeah. Hang on, do you?
No, you don't.
No, you don't. Oh, you get 1 over root 3 though, which then rationalizes, don't you? Because 1 over 2 times 2 over root 3. Yeah, so you would get this one. So if you did this one divided by that one, you do 1/2 times 2 over root 3, because you times by the reciprocal.
But you would get 1. Oh,
Yeah,
yes.
then you get that one, and then you rationalize it, yeah. So yeah, you could have worked it out just by looking at the triangle or by dividing tan theta by sin theta by cos theta, yeah. So it's because you asked about that, because I forgot to mention it. 45.
1.
Yeah, looking at the triangle, you can just see opposite over adjacent, it's just 1 over 1. And let's maybe prove so it's just equal to 1. Plus also if you did root 2 over 2 divided by root 2 over 2, you'd get 1. So it's only both ways. So 10.
Wait, because you said if you do another 45, you mean the other 45?
If you did it,
1 over
that
root
one,
2.
divided by that one. If you use that instead of TOA, tan theta equals opposite over adjacent. So this one's using tan theta equals opposite over adjacent. But you could have also use this one, tan theta equals sine theta over cos theta.
Yeah.
Because then sine theta divided by cos theta, it's just the same thing, so it equals 1. Dividing something by itself is just 1. So what is tan of 60 using the triangle?
Root 3 over 1.
Root 3 over 1, which simplifies to? Root 3, yeah. That's root 3. So same thing, if you did root 3 over 2 times 2 over 1, it would simplify to root 3. Tan of 90.
Undefined. This one's undefined.
Are we sure? Let's check with our calculator. Feels a bit weird, does it?
1
Let's try it.
divided by 0 is what?
It's error.
So you do get, you've done it already. Okay, good on you. Okay,
10, why we get that? 10 by 90?
tan of 90. Let's see if you want to see another thing to prove it to.
Math roll.
Hang on. I must be
Why you
in.
put 1 over 0?
Sorry, I was in radians. So I got an answer because I was in radians. I'll go back to degrees, which is what I should have been.
My biggest part is to do my exam and do wrong thing and not do this.
Yeah, so see, like Kiesha said, you get an error when you try to do tan 90. So just to sort of prove it to you as well. Huh? Sorry guys, I can't hear. Because tan of 90 is, we're using this one, sine theta over cos theta.
Why can't we use the regular one?
You can do anything.
Oh, you could, like, then you would get, because the right angle, you don't have an opposite and an adjacent.
Yes, you do.
So you can use hypotenuse.
Oh, right.
Yeah, it's a good question though.
That's it. Alabama.
Okay guys, can we just have a bit less extra chat, thanks, because this is kind of hard enough. Now we're going on to quadrant 2. We get some similar numbers, you just need to decide if they're positive or negative. We've already done 90 degrees, 90 degrees we've done already, so I'll just leave that one blank. If you did, using our... So we'll leave this one blank because we've already done 90, so that's over there. So if you did using the 30 degrees, remember you would kind of draw it up here. You would kind of go from here, you'd go back 30 degrees to make that triangle. So what we need to put here is what is that angle overall to make that triangle happen? What's this angle here?
Excuse me. Thing would be subtract 150.
Yeah, exactly. 180 minus 30, which is 150, yeah. So let's write in 150, and above it, maybe let's just write a little note of how we got that. So 150 degrees, and the way we got that was 180 minus 30. That's kind of how we got that. And same to the 45. We'd go 180 minus 45 to get this one. What would that give us?
135.
Yeah, 135 degrees. And then similarly, 180 minus 60, what would that give us? 120 degrees, yeah. And then to go all the way across to the next thing, like the next border of the quadrants, would be 180. Yeah. So I didn't bother to put 90 in. You could if you want, because but just 90's been done already. So that's why I just didn't bother to pop it there if you like. Cool. And then we'll just put the answers in.
So would 90 not be on the other side?
Yeah.
Wait, how
It's
is
kind of
90?
more a border. Like these ones here are more like borders.
Yeah, what's this?
You make
This one to this one. So it's just
Yeah, 0 to 90, 90 to 180. But we'd already worked out the answer to 90, so that's why I was going to just skip it off.
Okay, I just get confused.
Yeah, okay, 180 should be 90.
Yeah.
No, because she's looking from that way.
I know, but then I feel like it should be like
Sliding 150.
yeah.
Oh, I see, yeah. Because what this angle is, this angle, remember, it is kind of going like from here to here, but what this angle here is, yeah, exactly, it's that angle here.
Because you're going from this to here. You know, before you went from this to here.
Yeah, I'm trying to correspond them.
Like in the unit circle thing,
You just switch the order just to...
we went from here to here. Now we're going from here to here. That's why it's 90.
The reason that they're in different orders is because you're subtracting like the 30, 45, 60. And if you put it like numerical order, you have
Yeah.
to change for all the things. So
okay.
because it's going to be
So I got
exact
the
same
concept
thing.
of it, I just didn't know why it was going not like numerical order.
Yeah, and the reason why I've kept it in that order is these answers correspond to these ones, and these answers correspond to those ones, and those answers correspond to those ones, just to make it easy for you to sort of see. And then, yeah, so notice, so now all you've got to decide is, okay, in quadrant 2 is sign positive. You might just want to make a note of that.
Oh, yeah, she did.
Yeah.
This is negative.
Yeah, good. So you might just want to make a note of this one. This one's positive, and this one's negative. That might be a helpful thing. Positive and negative. Because sine theta is positive, it's just the same numbers above here. Because 150 corresponds to the 30-degree triangle, 135 corresponds to the 40 angle, 45-degree angle, and 120 corresponds to the 60-degree angle. So we can just go and write them in. You just have to decide if they're positive, negative. So they're all exactly the same as the ones above. But you've got to think about 180. Like 180, you just have to have a little think about it. Is it exactly the same? It's not the same as 90
How
because
come you put
90 is this way. 180 is over here. What's the height of that point? What's the y coordinate of that point?
180?
Yeah, 0, yeah.
0.
So for the last ones, you just have to think about it. They won't be the same as the ones above.
The sign is the y coordinate.
Yeah, sine is the y coordinate, yeah. And then cos theta, it's just the same numbers as the 3 above, but they're negative, yeah.
Equal.
Yeah, so when I work out these problems, I tend to work out, if it was cos 150, I would work out cos of 30, and then I'd make it negative, make an answer negative equal. Yeah, so root 3 over 3, pop a little negative on it. 1, pop a negative on it. Whoops, I'm looking at the wrong thing. I was looking at tan, sorry. Sorry about that, ignore those ones, they were tan. 3 over 2. Sorry. Negative
Stop!
2 over 2.
What? I'm reading the board.
You're clicking your ankles.
And then you've got to think cos 180. What's the x? Cos is the x coordinate. So the point is 180. It's close.
Negative.
Negative 1. Because it's in the negative part of the x-axis. And these ones just came from before. So tan, interestingly, is tan is sine theta divided by cos theta. So overall it's going to be negative, yeah. So if you want, you could have also put pos here if you wanted, just as little notes yourself. And then, so it's just going to be the negative of that one. Negative 3 over 3. And see, you've still got the same numbers as sine theta and cos theta, just one's positive, one's a negative. And then 0 divided by negative 1, so this one, 0 divided by negative 1 equals 0. 0, yeah. So for when you get to the boundaries, you have to actually think about those ones. Just copy in the numbers. This time you have to just think about them. Some people might still be unsure of why is cos of 180 negative 1?
Because the radius is 1, and since it's in a negative side of the x, probably be negative.
Yeah, exactly. Yeah. Because some people are looking a bit unsure why. And now quadrant 3, you could start up. Is sine positive or negative? Negative, yeah. What about cos theta? That is, isn't it? Yeah. And tan theta? Yeah, you've got a negative divided by neg. They can be helpful. If you want to, put in 180. 180's been done though, so follow that one down.
Evil. Wait, Miss Maloney.
Yeah?
How come you got root 3 over 3? Because wouldn't you do 1 divided by 2 times 2 over root 3 for 150?
Oh, if you do 1 over 2 times negative 2 over root 3.
Yeah.
Yep. Which would be, we'll do that one here.
Why do you have a root 3 on your bottom so you have to rationalize it?
Oh, yeah. So then you would get 1 over root 3 as your answer. Yep. And then rationalizing that times root 3 over root 3. Yeah. So if it was just working out, just leave it as 1 over root 3. And again, like sometimes the examiners mind if you leave it as 1 over root 3. Sometimes they don't care. But you just don't know. So I just
No, but wouldn't you
change
have a
these.
2 on the top? So it'd be 2 over...
Oh, no, it's because you've got 2 over 2. So you've got 1 over 2 times 2 over root 3. And the 2's kind of cancel down.
Okay.
Or you'd get 2 over 2 root 3.
Okay.
And then the 2 over 2 just cancels down to 1 kind of thing. It's good to know why, that's good. 180 degrees, and I need to keep that up there so we can see it. So, don't forget your little degree sign. What would be the angle here corresponding to the 30 degrees?
Wait,
Good guess? Good guess?
would you do 180 plus?
Yeah.
210?
Yeah, it's always from the x-axis. So to see, yeah, that's a good question. So to make it, you would do, to make the 30-degree triangle happen. Because you need it to be that angle. It needs to be that angle. So it'd be 180 plus, yeah. It's always from the x-axis. You either plus or minus from the x-axis. Yeah, so 210, yeah. So 210 degrees. Which maybe let's make a note, it was 180 plus 30. And what would be the 45?
225.
225, yep, don't buy a mistake, do 215, I do that for some reason a lot. 180 plus 45 is not 215, it's 225. And for the 60 degree one, 240, yep. And the next boundary is 270, yeah. And then the good thing is, it's negative though for the sign, so we've got to just pop them in as negatives. Same ones as above. 270, we've got to think about it. What would be the y, when it goes down, 270 degrees, point B, what would be its y coordinate?
Point P.
Yeah, negative one, yeah. I'll just show you why. Because from the unit circle. So it'd be down here. So down at 270 degrees is down here. Its y coordinate on the coordinate plane is -1. And then cos theta is -2, so we just put in the same one as above.
Wait, you have a negative there. Because you have a negative.
It's 0. Still weird, isn't it? Yeah, so 0 because the x coordinate of point P at 270 degrees would just be 0. And then tan theta is just the sine theta divided by cos theta. So you'll get the same as these, but they'll be positive. And then you've got to work this one out. -1 divided by 0 equals 0. Almost there. So as I said, some people memorize these tables, but it's better to just be able to work it out yourself. Yeah. Yeah, it's better to just work out what it would be in quadrant 1 and then just use the unit circle to decide is it positive or negative. Now, unfortunately in the CIE,
Just memorize like all the big ones. It's just the first one. We could have just made a unit circle.
But remember, he didn't teach it to us because we were reviewed and we were like, we don't need it. We did like hours.
Yeah.
oh yeah, in quadrant 4, is sine positive or negative?
Negative.
Yeah. What about cos? And what about tan? Because I net divided by cos, isn't it? And what's our angle going to be for the 30 degree triangle?
330.
Yeah, how do you get 330 degrees?
You subtract from 30 from 360.
Yeah, I'll just show you quickly why that's the case. So 330 degrees, you never add it from the y-axis. You always add it from the x. So you'd go back here. I'll do this one in purple maybe. You'd go down here and you'd make the angle there. Notice the angles are always here. Kind of like a Star Wars plane. So same thing for these ones. So what would be the next two angles? 315. Good. Yeah. And then we just bung the numbers in again. Oh no, we've got a 270 from there. 0, undefined. That's come from the other one. Under. 30 degrees, so we've just got to put in the number. It's negative. So it's the same as the row above actually. Just negative. That. And 360 we've got to decide what's the y coordinate of the point at 360. 0, yeah. Let's do cos is positive though. So we've got to put in the positives of the coses. What is that? What is the x coordinate of point D at 360? Positive one, yeah. And then tan is negative. 3. And then we've got to manually decide this one. 0 divided by 1 equals 0. So being able to do this kind of stuff is important not just in chapter 13, but when you get up to doing calculus, you might be asked to solve something, do some calculus and decide on which quadrant is the answers. There might be 2 answers, that kind of thing. That's at 9:42. Okay, we can finish there. Takes a while, eh?
Yeah.
And then we get to practice doing some solvey stuff. So the big theory, and then we'll probably do this and trig identities next lesson, because that's going to be pretty quick.
See, I'm just